Um, how many of you guys know what an agent is? Yes, of course. How many of you guys feel like life has become more sparkly? You know the sparkle emoji with agents. So this is the data-centric workflow now with like the sparkles with agents. So this is what I'm going to be talking about today. As I mentioned, my name is Harpreet Sahota. I'm a hack in residence at Voxel51. I've been at the company for about 2.5 years. Prior to this, I was working at a company called dataset AI. I was also at Comet ML and also Pachyderm. And before I was doing this kind of work, working in deep learning, I was a statistician of all things, data scientist, statistician, and then also an actuary. Who knows what an actuary is? Yeah, the most boring job in the world. So I decided to take my talents to a different field because at the end of the day, it's all just math and coding, right? So yeah, it's a little bit about me, and I'll share a link at the end of my talk if you're curious to connect with me. So how many of you here are familiar with the IEEE? Yeah, so this is like a simplified version of a talk I did for the IEEE last week. They invited me to come and do a talk. They're like, hey, can you kind of show us what 51 is all about, but then make it like specific to agricultural data sets. And so I haven't really worked with agriculture or agricultural data sets at all. So I just kind of spent a week downloading different data sets and kind of exploring them and kind of seeing what's out there in terms of agricultural data sets. And the result of that was a blog post that Claude wrote for me, but I published it under my own name. And it's right here. So if you're curious, you can check that out right here. And it gives you an overview of like all these different agricultural data sets. How many of you work in agriculture here by any chance? Yeah, well, like the talk's not going to be about agriculture. It's just going to be kind of like the medium for telling the story, I guess, for what we're doing. But even if you don't work in agriculture, like they still have a lot of the same issues that we're all familiar with. How many of you here work primarily in vision? Any type of vision. All right, so a good handful of people here that work in vision. And so just a warning. On this slide, there's an opportunity to get a limited edition sweater if you answer my question. All right. So of course, there's some messy realities here, right? That the agriculture has to deal with. So a lot of the times, like there's like aerial footage or footage captured from like a drone, not a drone, but what's that called? Like a rover going over some crops, right? And so you might have this issue of trying to take pictures row over row, right? And so of course, if there's overlap between those rows, you might end up with a lot of near duplicate frames, right? So this, of course, is not good to have in your data set. You want to try to deduplicate it as much as possible, or at least make sure there's not this leakage between your splits, right? So this is a challenge that we're kind of all familiar with if you work in vision. You might have like a handful of crops that dominate the farm, and then you might have some rare weeds that show up maybe once or twice. And there's like a technical name for this. And if you answer, if you let me know, raise your hand, let me know. What's this technical name? What's it called?
Class imbalance.
Yes, exactly. Class imbalance. You're gonna get a sweater. Talk to me after the talk, or just handle it now. Yeah. So yeah, class imbalance. It's class imbalance. There's a lot of annotations that are usually done manually, often by different people at different times, different states of mind, and of course this leads to inconsistent labels, different lighting conditions, soil types, things like that. Of course, this is domain shift, and of course all of these kind of data quality issues, they'll affect the model performance at the end of the day, right? So what's that old saying, like garbage in, garbage out? It's still true even now. So all this work of cleaning up this data set, this data curation work, it's not really sexy unless you're me sitting in front of a computer doing it, then it might be a little bit sexy. But it's drudgery, it's boring work, and it's not fun to do. Really not fun to do. It's grunt work, but it's important work, very important work. At the end of the day, this is what drives model quality. And it's not really constrained to just vision. Of course, these same issues, this same concept, this data quality concept, data curation concept is extremely important with language models, and of course now with robotics and all the different applications of machine learning out there. And it's kind of like solving a puzzle in real time. It's quite fun. So I'm curious, how do you guys typically explore your data sets? For those of you, it doesn't matter vision or language or robotics, like how are you guys, by the way, this is an opportunity to get a sweater. So how do you guys typically go about exploring your data sets? Yes?
Trying to visualize the first rows or the first images, and then also just doing some very basic visualizations.
Yeah. And what's that process typically like?
Data exploration?
Yeah. I mean, but yeah, what's it like? Like, what are you doing during this process? Does it look something like this, where you're opening images one at a time, and then?
I typically do it in VS Code, but
okay.
more or less that's the same thing.
Yeah.
Yes, more or less will be make it to open it for you.
Yeah, you're looking at images one at a time. Maybe you open the CSV, you're looking at the bounding boxes, you see a list of integers, and you're like, okay, that's great. I don't know what that means. And then maybe you have like segmentation masks, and of course, like your segmentation mask, when you open it up, what's it going to look like? It's probably going to be just completely black, and that's not helpful. And you can't really understand what's in the image that way. And so, what do? Well, before a few months ago, maybe you wrote some code and you did it yourself, but now maybe you just like open Cursor and ask it to just collate the labels on top of the images and do it that way. So here, like I'm just using Cursor here to ask me to visualize exactly what she said. Do what she said here to visualize what's in the data set, and it does a thing, and he writes a little bit of code, and then at the end of this, we get like this cool little plot here that we can look at. But of course, that's not very like scalable. It's not very fun to do. This is drudgery. This is like the boring work. This is unsexy work. But you have to do it, right? You have to look at your labels. You got to look at your data. But it could be more fun, of course, if you use 51. So 51 is actually open source, right? So it's just a toolkit for visualizing, curating, kind of understanding what's in your data set. So here we're not just like looking at an image. There's an interactive UI. This is all, if you pip install 51, you're running it locally, and you're seeing all this locally, and the browser app is running locally as well. And it's interactive, and it's built to kind of visualize your data set at scale. So you're able to filter, sort, tag, and query across millions of samples all at once. So you can see here we had the labels, we've got metadata, we can also do embeddings and model predictions, and all of it kind of lives in one place that you can explore at once. And so it's programmatic and it's visual, and they're side by side. So when you pip install 51, there's like the 51 SDK, and then there's the app. So there's two kind of sides of the same coin. So anything you see in the app is going to map directly to any Python that you run. And this is kind of the canvas in which we're going to be seeing how to use an agent in the 51 app here. So instead of doing what we did before, we're asking the model to kind of draw boxes from scratch and working on just PNG plots that are created in Plotly. We're going to be doing something more interactive. And this is nice because it's queryable, taggable, and inspectable. There's a lot of like cool stuff you can do with 51. There's a lot of like bread and butter stuff. You can filter, tag, sort, query, all that stuff. But there's also extensibility built into 51. You can build plugins and you can build panels. You can see here I'm looking at an embeddings plot. So I'm visualizing the entire data set. And you can do it 2D, 3D embeddings. And this is helpful when you're trying to spot clusters and outliers and duplicates and things like that. So you can click on a point in the embedding plot, jump straight to that corresponding sample in the grid, and then you're doing this visual kind of exploration here. You can see here there's a panels below that. In this case, there's a dashboard panel. So you can build these custom kind of panels, and you can actually encapsulate workflows via plugins and robust, very plugin framework. And this is nice because this is where the aha moment happens, right? And it's allows you to catch these patterns that you might not see if you're just scrolling image by image. And so the data set we're going to work with is called the crop and weed data set. And so this is about 8,000 images, 112 hand-drawn plant annotations. We have 4 different growing seasons here, 929 recording sessions. We've got bounding boxes for the actual plant detection. We got key points that mark where each plant's stem is positioned, and then a full per pixel segmentation mask underneath it. And there's also different metadata here. There's like condition tags that describe exactly how it shot that day. Like, so the moisture, soil type, lighting, and then also this measure of separability. Is it hard to separate or easy to separate? So, a lot of rich metadata here. This data set, if you're interested, is already uploaded on the Hugging Face Hub, along with almost 200 other data sets. So all these data sets, like I said, you pip install 51, then you go to the Hugging Face Hub, huggingface.co/voxel51. Look at the data sets, and you can see we've got a ton of different data sets up there that you can explore. This specific data set, I actually made it available in a Hugging Face space. So if you're curious about clicking around in the data set that you are going to see today, you could do that right here. So of course, there's a lot of cool, interesting stuff that you could do with 51, but I want to just focus on 2 kind of new things that we have pushed in our latest release, specifically the 51 agent and then in-app annotation. So we're going to use the agent to kind of get a high-level overview of the data set. We're going to compute some image quality metrics, for example, brightness, blurriness, entropy, like the standard things you can get with OpenCV. We'll assess class imbalance. We'll try to identify if there's any domain shift. We'll do some geometric kind of quality assurance by looking for kind of degenerate bounding boxes and possible annotation mistakes. Then we'll fix those annotation mistakes in the app, fine-tune a model on that curated data set, and then evaluate the model. So I'll show you how to do all of that really without having to write any code, and all within the app. All right, so this is a opportunity to get a limited edition sweater here. So it's not here. So the 51 agent, right, it's built on 2 things. There's skills and MCP. Anybody want to define what a skill is? Yeah.
An extension, let's say, for agent like code or codex to get specific knowledge to implement properly the code, and the MCP model context protocol, let's say it's like USB-C for AI.
Okay, great. So I was going to ask what MCP is on the next one, but you get one. You only get one sweater. But yeah, right there, blue shirt, 3rd row, yeah. Yeah. So a skill is basically like a handwritten, human-authored workflow. It's not like prompt engineering, but it's closer to an onboarding document for like a new teammate. So we outline the goal, the prerequisites, and the exact sequence of steps that we need to take, and then also leave some clues for what might typically go wrong when performing workflows. And then we have MCP. So we already got a definition here for what MCP is, but at a high level, it's just an open standard that was developed by Anthropic, and it lets essentially a model connect to external tools, data sources, and services through like a unified interface. So rather than having a custom integration for each one, we have like a unified kind of interface to connect to these different tools and things. And so skills is like the complementary concept here. So skills and MCP kind of go hand in hand. If you're curious about learning more about agents and the importance of tools, my colleague Adonai has written a really good blog post here. Your agent is only as good as the tools you give it. So he shares a lot of cool lessons that he's learned building the 51 agent. So Adonai is the brain behind the 51 agent. He's the guy that kind of brought it into existence. So a lot of cool lessons that he's learned here. So at a high level, using the 51 agent is something like this. First, you'll configure the agent. Maybe you can connect to any model that you want. You maybe have some custom system instructions, user instructions, and then you can have dataset specific instructions. And then you have like all these skills that come shipped with the 51 agent. And so all of these skills, as you might have saw, were grouped by what they accomplish. And then you can actually switch skills on and off per conversation, because maybe not every workflow belongs in every conversation. So each one follows this open specification that we had mentioned before. It's a skill.md file. Has like the overview, prerequisites, key directive, workflows, and kind of troubleshooting steps, all in that skill. And to use it in the app, well, you can just directly just click a skill to use it. So here, I'm looking for a dataset discovery skill, and this will actually look at all the 51 datasets I have in my environment, give me a brief overview of each one. And then after I do that, I'm clicking around and I'm using a data quality skill. And so this data quality skill is just going to compute image quality metrics for me, like blurriness, entropy, brightness. So these are standard kind of OpenCV methods that we can use to understand image quality. And so I could do all that right there in the app, see the results live, and it's interactable as well. As you see here, well, you'll see in the next slide what we do with the image quality, but here I'm just demonstrating that actually we could ask the agent a question using natural language. So here I'm just asking it to give me a quick overview of the data set, media type, label fields, and anything unusual in the metadata. So it's using the skill and giving me a high-level overview of what's in the data set. And this is what I kind of do to understand quickly what's in the data set and keep in mind what I notice. And so you'll see here that it mentions something about the session not being unique, and it mentioned that there's some kind of class imbalance that we should inspect. So keep that in mind as we progress through the slides. So while the agent was doing this initial dataset overview, we noticed that actually vegetation is highly overrepresented in the dataset. So I asked, why is it so overrepresented? So I asked it to make a histogram of all the ground truth labels. So behind the scenes, it's doing the aggregation, opening the histogram panel, and then tells me kind of what I'm looking at high level. 84 classes, over 100,000 detections, and then one big problem. The vegetation class is nearly 30% of everything, and it's not even like a real species. It's just a fallback class. And then tells me actually it's fallback class with the class ID being 255. And so the agent then offers to build a view for me, which will filter out all those annotations in the vegetation, so I can get a kind of more clear overview of what the class distribution is in my data set. So one click builds a view, and now the real species distribution, plant species distribution, becomes more apparent. Of course, no code, and it's done under a minute, and it's just using the standard 51 SDK under the hood to compute these queries against the data set. I could ask the agent to take a step further. So instead of a one-off histogram, I asked it to build me a dashboard that I could work with. So this is an interactive dashboard. So it creates the dashboard, wires up the plots, and then I kind of take over from there. So I'm looking at the label distribution. I see the same imbalance we saw before, but it's interactive. So I can click on a class in the chart, then the grid will instantly filter to just those samples. So now I'm not staring at just a bar chart. I'm looking at the actual images that correspond to those values in the bar chart as well. So the agent is doing the setup work, and then I'm doing kind of the exploration. So you can see here we got statistics on one side and then real samples on the other. So I'm still driving the dashboard here. And so as I mentioned before, the dataset ships with some environmental metadata. And so the dashboard is kind of breaking all that down for me. I've got the soil, moisture, I've got soil type, I've got lighting conditions, as you can see here. And in this case, like lighting conditions is something that piqued my curiosity. So I click on that, open the histogram for the brightness values, and kind of assessing if there's any, what the distribution of brightness is like. And you can see it's, fairly normally distributed, except for that one clump over to the far right. And this gives you more insight as to what's in the data set itself. Any opportunity for a question, for a sweatshirt here. How do I phrase the question? So any do you have a story that you might be able to share? Like what could happen if we were to train a model on a data set like this, where we have kind of, this domain shift? What are some potential things that might go wrong? Any ideas here? Overfitting, yes, right. Overfitting. Because if we have a model that's mostly trained on one condition, it might quietly fail on a different condition. So we'll get you a sweater there. And so now I'm able to kind of assess this, and I haven't written any code at all. I haven't had to click on images one at a time. Like, I'm doing everything right there in the app. So I know exactly how many samples fall in each one of these buckets, and I can check whether there's like an even split between the training set, validation set, and all that as well. So one of the key features of this data set was, the authors were very proud of the fact that they thought very clearly about redundancies and took what they thought were the best steps to avoid redundancy. So so this is like a rover going over rows of a field, and they were careful just to take images every 3 meters, so they could avoid near duplicate frames. And so here I'm just assessing whether this actually worked from a embeddings model point of view. So prior to this, I had asked the agent to compute embeddings and then compute the visualization of those embeddings. So I used clip embeddings here, and then asked it to compute a uniqueness score for each one of those points. And I noticed actually through this that there's one session, it was called application set 67, that accounts for a lot of the redundancy in the data set. So this spacing rule that they had kind of hoped would work actually ended up failing in that one field. So we noticed that there's a lot of redundancy in that one specific field. So here I take a different kind of approach. Now I'm looking kind of a geometric quality assurance. So I asked the agent to find detections in the ground truth with a bounding box area that's smaller than some threshold, and also to help me find the stem points, which are the key points that are supposed to identify where the stem is. I wanted to see if there's any of those key points that fall outside of a bounding box. And so I manually opened up a plot here myself just to kind of audit what it is that the agent is doing. And of course, this is quite an annoying query to write by hand if you're trying to compute bounding box area across your entire data set. It's an annoying query to write by hand, but the agent just builds the view for me, and it's using just the 51 SDK behind the scenes. And we're able to then find those degenerate bounding boxes and then the key points that are kind of contradictory. And so this is quite straightforward to do. And of course, if there's code that doesn't require, like if there's queries that you have that are too complex, or maybe you can't natively do with the 51 SDK, the agent will actually just write code and execute the code against the data set in Python, pure Python for you as well. So just demonstrating that we could do that as well. So here, like, doing that geometric QA, and then I'm looking at some samples in particular, and I'm seeing that there's some samples where the stem point is sitting outside of the bounding box. And so it's kind of an annotation defect there. Of course, they're hand-drawn annotations. And so just to prove the point, here's open another one, and we see the same type of issue. So we're able to identify these kind of annotation errors and these annotation mistakes. Just demonstrating the same thing here. So now I'm kind of armed with this knowledge of that the agent has provided me, and I can ask it to create a triage queue of samples for me to go triage, and then I can go in there and I could fix annotation errors live in the app. So here specifically, I'm fixing annotation errors for degenerate bounding boxes. So you can see here we have annotations where it's supposed to be vegetation, but it's like such a small bounding box, right? It's not even covering the entire instance. And right there within the app, I'm able to fix those annotation errors on the spot. So kind of doing this iterative workflow with the agent, just chatting with my data, so to speak, I'm able to identify these annotation errors and fix them on the spot. I can do the same thing with masks. So in this case, For a limited edition sweater, somebody want to tell me what the difference is between a bounding box and a segmentation mask? Yes.
So, if you want to visually inspect it, the bounding box, as it says, as the name suggests, is a bounding box that covers the entire object itself.
Yeah.
But when you're talking about a segmentation mask, you're just covering the object itself.
Yeah.
So in a bounding box, you're covering the plant and the ground around it,
Yeah.
covering all of it. But if you segment just the plant itself, you're not going to account for the ground behind it.
Yeah. Yeah. So just the kind of exact pixel level shape of the
More
thing that
detail.
is. Yeah.
Yeah,
Exactly.
more detail.
Yeah. And so kind of the premise of this data set was that every bounding box was paired with a segmentation mask. So here I asked the agent to help me identify those bounding boxes that did not have a segmentation mask corresponding to it. Identified those, and then right there within the app, I'm using, in this case, SAM3, just dropping a couple of points and creating a segmentation mask for those instances that don't have it. I can do the same thing with primitives as well, so not just bounding boxes or segmentation masks, but here I'm changing, like, for example, I could change or fix the soil condition, lighting condition, things like that. So you can do it with more than just bounding boxes. You can do it with primitives as well. This is not clicking through for some reason. There we go. So once I've done this data quality audit and I've curated the data set, I can export it to one of the common formats. So here I'm kind of doing the manual old workflow you do in 51 where you export it by hand. In this case, exporting it to COCO format. Of course, you can export it to any one of the common formats. In the next slide here, I'm actually asking the agent to do this for me. So ask it to create a view that's from one of the curated views that we've built, and then train an Ultralytics YOLO model. So it'll export the data set in Ultralytics YOLO v5 format, train an Ultralytics model for me. It does it all kind of behind the scenes without me having to write the code myself. And once that's done, ask the model to evaluate the performance of this fine-tuned model. And so here in the app, I'm just looking at this evaluation of the model performance. So here, get the high-level overview, then I could do different scenario analysis, so I could see how well the model performs in different lighting conditions, as well as different soil types as well, or any other primitive that I have. So we're able to see this model performance at an even granular level. And so that's basically it. That's my talk. A few more slides to close it. But we did this kind of loop where we ingested, explored, improved, and then now that I've seen the model performance and the evaluation results, I could iterate from there as well. So to recap, we ingested the crop and weed data set, chatted with the agent, curated some subsets of the data set. We explored it, found imbalance, domain shift, embedding redundancies, and then did some geometric quality assurance, fixed the annotations right there in the app, and then finally fine-tuned the model and evaluated the model performance all right there in the app without having to go back and forth between Python script and the app. If you're interested, I'm hosting a workshop in a couple of weeks, a virtual workshop. The whole premise of this workshop is we'll start with an unlabeled data set. We'll bootstrap labels and kind of go through this process of essentially kind of bootstrapping labels and fine-tuning a model and then assessing the performance of that model, all using the open source 51. I won't be using the agent at all. We'll be mostly writing code in this session. So feel free to register for that. I'd be happy to have you there. If you thought this was interesting and you now want to kind of see 51 in action on your own data set, whether it's your research lab or with your colleagues, you can scan this QR code. You can book a workshop completely free, and we'll use the open source library. We can work with your data sets. We can work with a good proxy for your data set. And I'll show you how to kind of get hands-on with 51. So definitely check that out if you're interested. At the very least, if anything, it'll bring me back here to Paris. So if you book a workshop, that gives me a reason to come back here. Maybe stay for even a little bit longer than I am this time around. I'll take questions at the end.
So
I'll come to you in a couple minutes. One more slide, and I'm gonna come to you. So let me wrap up here. So yeah, if you're interested in booking a workshop, please do. Feel free to connect with me on X. That's kind of primarily where I'm active these days. I ended up getting like one of those LinkedIn influencer things, and I was like, dude, I don't want that. So I stopped being active on LinkedIn. Sorry, LinkedIn. You guys are great though. But connect with me on X. That's kind of where I want to be. And you can keep up to date with all the cool stuff that I'm shipping. I think just this year alone, I've probably shipped maybe, I don't know how many integrations, but like model integrations, dataset integrations, cool plugins, and different integrations with different dev tools. So it's a good way to keep up with what I'm up to is on X. So that being said, thank you very much. Appreciate you guys being here. And I'll take some questions.